Let us first write the formulae of this chapter, work and energy. See, the first formula you have to remember is the formula from the previous chapter where force is equal to mass into acceleration. If it is acceleration due to gravity, then it is force into gravitational acceleration. Then, after that, the second formula is work is equal to F dot S. Work is equal to F dot S, right? The next formula is that kinetic energy is equal to half mv square and potential energy is equal to mgh. Now, we also have learnt about power in this chapter. So, power is equal to work upon time. And we can say that energy consumed, that is this actually is this work formula only. So, energy consumed is equal to power. But your power has to be in kilowatts multiplied by time. Energy consumed is equal to power into time. Now we will do a few sums which are there, which I have written down for you. Right now, this is the first question. Let's read the question together. Calculate the work done to take an object of mass 20 kg to a height of 10 meters. Now we are taking g as 10 meter per second square. So what is given to me? First let me write down what is given to me. It is given to me that mass of the body is 20 kg. And height is 10 meter. Now G, I told you before, if they don't give you the value of G, you take it as 9.8, but here they have given it to you as 10 meter per second square. So we'll write it as 10 meter per second square. Now you're taking an object to a height, therefore I have to find the work done. So since the object from the ground, it is lifted to a height h, the work done is equal to the potential energy of the body, right? Is equal to the potential energy of the body, which is equal to mgh. Now my mass is 20 kg, g is 10 and height is 10 meter. So work done is equal to 2000 what? Joule, right? Therefore, work done is 2000 joule. Okay, it's 2000 joule. Next, five hundred kg of water is stored in an overhead tank of 10-meter high building. Calculate the amount of potential energy stored in the body. Right? So what is given to me? It is given to me that the mass of the water is 500 kg. Height of, at a height of 10 meter, right? Calculate the amount of potential energy that is stored in the body. Now here they are not giving you the value of G, right? So when they don't give you the value in the sum, you have to take G as 9.8 meter per second square. We have to find potential energy. Now, what is potential energy formula? Repeating, potential energy is equal to mgh. Do we know how much potential energy is? No. So we'll copy it as potential energy. Okay. How much is the mass? Mass is 500. How much is G? G is 9.8. How much is the height? Height is 10 meter. My unknown is on the left hand side. So I always do these sums in this manner. Now because it's on the left hand side, I don't have to touch anything, right? So 500. What do I write it as? I'll write this as 98 upon 10. If I remove the decimal point, it becomes much easier. And upon this 10 and 10 gets cancelled, right? So this becomes 98 into 5 is 490, correct? 490, and we have to put two more zeros. So 49,000. What is the unit? The unit is 49,000 joules. Therefore, potential energy is equal to 49,000 joules. Simple substitution of formulae. Very, very important to learn numericals in physics. Okay, next. A stone having mass 250 grams is falling from a height. How much kinetic energy does it have at the moment when its velocity is 2 meter per second square? So what is given to me? It is given to me that mass is equal to 250 gram. Now this gram I have to convert to kilograms. So I'll do 250 upon 1000. Cancel these zeros, 2 places. So that's equal to 0.25 kg. Right? I can write 25 upon 100 also. It becomes easier to cancel. Velocity here is 2 meter per second. This is, so I have to find out the kinetic energy. So to find kinetic energy, so see my solution. What is my kinetic energy equal to? Kinetic energy is equal to half mv square. Do I know kinetic energy? No, I have to find it out. So it's on my left hand side, right? Half. What is mass? See, I can take as 0.25, but I prefer taking it as 25 upon 100. It becomes easier for calculation. Into 2 into 2. Is that clear? Okay, so now I have to cancel. I'll cancel this 2 and this 2, right? 25 2s are 50. 50 upon 100. Correct? 50 upon 100. Cancel this 0. 10 means a single place, so that becomes 0.5. Again, kinetic energy also is measured in joules. Please write the answer. Kinetic energy is equal to 0.5 joules. Is that clear? Now, the next question. Swarali takes 20 seconds to carry a bag weighing 20 kg to a height of 5 meter. How much power has she used? How much power has she used? Okay, so let's see what is given to us. It is given that Swarali takes 20 seconds. So seconds means time. Time is 20 seconds. To carry a bag weighing 20 kgs. So mass of the bag is 20 kg. Okay. To a height of 5 meter. So height is equal to 5 meter. Right. How much power has she used? How much power has she used? Correct. So power is equal to, so she has to find, I have to find the power. Correct. Now we know power is equal to work upon time. So first let us calculate the work done. So solution. The work done by the body, okay, is equal to force into displacement. Now I told you what is force. Force ka equation also I found out. I gave you the formula. I told you force, remember, is equal to mass into acceleration or mass into gravitational acceleration. Now she's carrying the bag, right? So therefore this is m into g into s. Okay, displacement, right? Now we know how much the mass is. Mass is easy, it is 20 kg. What about g? G, I told you, whenever you require, if they have not given you, you can take g as 9.8 meter per second square, right? So this is 9.8. Is that clear? Now the next one, into s, the displacement, to a height of 5 meters. So this is the displacement of the body, right? That is 5 meters. So here h is equal to s. That's why I'll put it out here. Okay, so this is equal to 5 meter. So that is 20 into 98 upon 10 into 5. So I'll cancel this 2. 5 2s are 10, 10 9s are 980 joule. Now what is the power? How much is the power? Power is equal to work upon time. Power is equal to work upon time. Okay, so let us find out how much is the power. Power is equal to work done upon time taken. Remember, time always has to be in seconds. Now how much is the work? Work done is 980. Time taken to do the work is 20 seconds. So this 0 and this 0 gets cancelled. So my power is equal to 249 49. Okay. Seconds. 49 watts. Right. Okay. So in the textbook it is given as 40 seconds, which is not correct. Okay. This is the answer. Now see the last question of the solved examples, right? A 25 watt electric bulb is used for 10 hours every day. So what is given to me? It is given to me that power is equal to 25 watt, which is equal to 25 upon, I always told you, for energy consumed we have to convert it to kilowatts. So kilowatts means I will divide by 1000. So 123 123, so that is equal to 0.025 kilowatt. Correct? This is my power, right? And 10 hours every day. So Here we don't need to convert it to seconds. We'll keep it as 10 hours. For how much electricity does it consume? So energy consumption, right? So solution, first we need to find energy consumed. So energy consumed, okay, I gave you this formula, okay, is equal to power, but the power has to be in kilowatts, into time. Time has to be in hours, right? This is different, right? So this is, I'll write this as 25 upon 1000. It becomes easier for me to cancel. Into time is 10 hours, right? So this 0 gets cancelled. So it becomes 0.25. Now what is my unit? Kilowatt hour. This is my unit. Please remember, kilowatt hour. This is the unit for energy consumed. Therefore, write the answer. Energy consumed is 0.25 kilowatts